Hello guys, hello. So today we'll be doing geometric sequences, not geometric series. Okay, so I kind of like this topic more of that. It's because it's kind of like broad and everything, and we're gonna be mixing exponents as well. So we're gonna start with the sequence and then the series as well, because we also have to go back a little bit to deal with some services on the other patterns, okay? Like the previous ones, right? So, what you guys need to know is that with a geometric sequence, you need to know that a geometric sequence is a sequence of numbers in which the ratio between consecutive terms you know, are constant or equal, So here I was supposed to say the ratio between here and not of the between consecutive terms is constant or equal, right? So this is the origin. This one is not even complicated that much. This right here is the equation for a what geometric sequence. It's Tn equals to ARn minus 1. Guys, you must familiarize yourself with exponents here because we're gonna be doing exponents. When you see geometric, you must think of exponents, okay? So the actual formula for the sequence, it's Tn is equals to A R n minus 1. The A right here is the first term, which is T1. The R right here is the what? Is the ratio. The ratio it's actually obtained from what? Two consecutive terms or numbers, okay? So we get the ratio by saying T2 divided by T1, T3 divided by T2, T4 divided by T3, T5 divided by T4, and so on and so on, right? So that's just it. You must just know what the A stands for and the R stands for, because the S for the N, it doesn't change, it's still the same. Okay, so let's take an example. Okay, so here's an example. There's this pattern, and we were told this pattern is a what? It's a geometric sequence. Okay, so let's just read the instruction before you answer the question. Okay, so it says that write a formula for the geometric sequence below, which is this one, which is 3 6 sorry, 3 6 12 24 and 48, right? I said our A is what is the first term, which is what? T1. And in this case, our first term is what? It's 3, right? So meaning good to we have our A already. We have our what? Our A already right here. It's what? It's the first term. But the ratio, again we said it's the ratio between what? Two consecutive terms. Meaning we take our T2 divided by T1, T3 divided by T2, T4 divided by this one, T5 divided by this one, and so on and so on. The answer is not we must get. The ratio is constant, meaning it's equal, meaning it's equal. You see the ratio between 6 and 3, it's what? It's 2. 12 and 6, it's what? It's 2. 24 and 12, it's what? It's 2. 48 and 24, it's what? It's 2. This right here is our ratio. Okay? So what we have to do, I even wrote them down, that 6 divided by 3 is what? 2. Or 12 divided by 6 is what? This divided by 6 is what? So when you answer this question of the ratio and everything, you can just do this. You see this method I used right here? You can just do this with just like two answers. You can just do it 2 or 3 answers, but not just one. Just take 2, okay? And then you do this, you say R right here, it's equals to 2, 2, 2, 2, 2, 2, 2. In this case, our ratio is 2, okay? But in other cases, the ratio can change depending on the pattern that you're given, okay? So now that we have our 3 right here, which is our first term, and our ratio, which is what? Which is 2. we substitute or insert our a and r in the equation. Okay, so that's what I said. Therefore, Tn, before you substitute, you write the equation first. Okay, Tn is equals to what? Ar to the power what? N minus 1. Okay, so our a is what? It's 3. Substitute our 3, and then our ratio is that it's 2 to the power what? N minus 1. So it's always good for you guys to what? To test your equation, just to what? To be sure. You know me and testing. I test. Okay, so let's use the T1. In this case, our T1, we know it's equals to what? It's equals to 3. Okay, so we must get 3 for T1 in this case, just to be sure that our equation is okay, it's correct. Okay, so it's a T1 equals to what? 3 into 2, I mean close brackets right here, 2 Leona close brackets to the power at 1 minus 1. Where you see the n, you substitute what? The 1. Okay, so the n is up here, we substituted our 1 right here, minus 1, which is this one. Okay, so okay, here it's just 3 and 2. These ones don't change in the brackets, but 1 minus 1 is what? It's 0, right? So we have 3 by, but okay, by 1. This one I obtained it from this one right here, because we all know that any number to the power 0, it's what? It's 1. 100 to the power 0, it's what? A million to the power 0, it's 1. Any number you can think of, for as long as it's to the power 0, then it's 1. Okay, so that's how we got the 1, because 2 to the power 0, it's what? It's 1. So 3 times 1 equals to 3. And proving this point good to it's true, you see our T1 is equals to 3, and you know, when we like tested our equation with T1, we got 3. So this equation is correct. Therefore, the formula is correct. So this, you don't have to do this part in your answer sheet or your exam book or your test book, or I mean not test book, your class book or anything. This one you just do it aside. This is for you to be sure with your answer. Your answer must just end here when you answer the question of you asking of you writing the equation for the geometric sequence and everything. You just leave it right here, and then there's one right here, it's for you to do on your like scribbler or whatever you're gonna be using, that's kind of like extra and all those things. Okay, so yeah, this is just what it is for today. So I'm just gonna gather some questions for you guys and then stop them, and then do the series as well.